All right, let's get right into it. I'm about to tell you something that's going to sound, well, it's going to sound completely nuts. Gravity is a lie. And look, before you write this off, this isn't some late-night conspiracy chat. This idea gets to the absolute core of one of the biggest, most fundamental problems in all of modern physics, a problem that the smartest people on the planet are racing to solve right now.
So if it's not what we've all been taught it is, then what in the world is it? To get to the bottom of that, we're going to go on a little journey together. Think of it like leveling up our understanding through 4 different stages, starting with the stuff you probably remember from school and ending up at the absolute bleeding edge of science.
Okay, level 1. Let's start on familiar ground. For hundreds of years, pretty much our entire picture of the cosmos was built by one person, Isaac Newton. This is the gravity you know and love from high school physics.
The idea is it's intuitive. It makes sense, right? Anything that has mass pulls on anything else that has mass. So the Earth, being absolutely massive, pulls you down, keeps you from floating off into space. But, and this is the cool part, you're actually pulling back on the Earth with a tiny, tiny little bit of force.
And the math he came up with to describe this pull, it is just beautiful. So elegant. This one little formula can tell you the exact strength of that pull between any 2 objects in the entire universe. It's incredible.
Let's break this down real quick. Up top, you just multiply the masses of the 2 objects. The bigger they are, the stronger the pull. Simple. But the secret sauce, the real magic, is on the bottom. You divide by the square of the distance between them. That's the inverse square law. And what it means is that if you double the distance, the force gets 4 times weaker. That's why you don't really feel the pull of Jupiter. It's just too far away. The result of all that math is F, the force. It worked perfectly for a while.
So now we get to level 2. And this is where the story gets a major plot twist. Because a guy named Albert Einstein came along and he didn't just tweak Newton's ideas, he completely blew them up and rewrote our understanding of space and time itself.
It all started with a thought experiment. Imagine you're in a sealed room with no windows. You feel your feet pressed against the floor. How would you know if you were sitting on Earth feeling gravity or if you were in a rocket in deep space accelerating upwards? Einstein's mind-blowing answer was, you couldn't. There is no experiment you could do to tell the difference. They are the same thing. Now, let's flip that idea. If speeding up feels like gravity, then what should the opposite, free fall, feel like? It should feel like nothing. Weightlessness, just like floating in empty space. And this is exactly what astronauts in orbit feel. You know, they aren't really floating. They are in a constant state of falling toward the Earth. They're just moving sideways so fast that they keep missing it. And this is the absolute key. If you can enter a state, like free fall, and a fundamental force of the universe just vanishes, then was it ever really a force to begin with? This is when it clicked for Einstein. Gravity isn't a force at all. This is the huge shift in thinking. Newton saw gravity as an invisible rope pulling things together. Einstein's view was so much bigger. He said massive objects don't pull on other things. They literally bend and warp the fabric of reality, this 4-dimensional thing we call space-time. So objects aren't being pulled. They're just following the straightest possible path through a curved space. You know, here's a great analogy. Imagine 2 people start on the equator, a few thousand miles apart. They both start walking in a perfectly straight line, due north. What's going to happen? Eventually, they'll bump into each other at the North Pole. But was there some weird force pulling them together? No, of course not. They were just moving in straight lines on a curved surface. That's gravity.
And I want to be clear, this isn't just some weird abstract thought experiment. This matters, like in your pocket right now. The GPS on your phone only works because the satellites orbiting up there are constantly correcting for Einstein's warped spacetime. If they just use Newton's math, your location would be off by kilometers, every single day.
Okay, so Einstein solved it. Gravity is just curved spacetime. Case closed, right? Well, no, not even close. Let's move to level 3, where we run smack into the biggest, most frustrating problem in all of physics. See, physicists have figured out there are 4 fundamental forces that run the entire universe. And we have an amazing theory, quantum mechanics, that perfectly describes 3 of them, electromagnetism and the 2 nuclear forces. But then there's gravity. It's the odd one out, it's the problem child that just refuses to play by the same rules. So here's the conflict in a nutshell. We have two sets of rules for the universe, and they totally disagree. Einstein's general relativity works perfectly for big stuff, planets, galaxies, and it describes a universe that's smooth and continuous. But quantum mechanics works perfectly for tiny stuff, atoms, particles, and it says the universe is chunky, pixelated, made of these little packets. The universe can't be both smooth and chunky at its most fundamental level.
So why is gravity so stubborn? Why can't we just describe it with quantum mechanics like the other forces? Well, for one, we can't seem to find its fundamental particle, a graviton. But the even weirder part is what we already know. You can make it disappear just by falling. You can't do that with magnetism or any other force. It's just different.
And this brings us to our final level, level 4. This is the modern quest for what is basically the holy grail of physics, a single theory that can finally unite these two warring ideas, a theory of everything.
The dream is to find one single, elegant set of rules that describes all the forces of nature. A theory that explains how a black hole works and how an electron works, all in the same breath. It would be the absolute pinnacle of human understanding.
And scientists are throwing some truly wild ideas at the wall to see what sticks. You've got string theory, which says maybe everything is made of tiny vibrating strings and gravity is just one of the notes they can play. Or loop quantum gravity, which suggests space-time itself is made of indivisible pixels. These are hugely complex ideas, all trying to find a language that both sides of physics can speak.
But it is an absolutely monumental challenge. I think most physicists are driven by this deep belief that the final answer has to be simple, it has to be elegant. But we have to face the possibility that it's not. What if the universe is just messy and complicated in a way our brains aren't built to understand?
Think about this, though. Every time our understanding of gravity has taken a leap forward, it has completely changed our world. Newton's laws gave us the Industrial Revolution. Einstein's ideas gave us the nuclear age and GPS. So if we finally crack this, if we finally solve the puzzle of quantum gravity, what happens next? What could we build? Warp drives? Controlling black holes? It leaves you with this one last incredible question. If gravity isn't a force and space-time is maybe just an illusion, what is the universe really made of?